Okay, so here's problem 17-18. Just another example of how we can take a complicated object and break it into its components. So let's see what we have. We have a disk connected to a rod, connected to a rod. Okay, now I have chosen to call this disk A, to call this rod O, and to call this rod B. All right, that was my arbitrary choice. It worked for me to make things just a little bit simpler. So we need to get the masses, M sub A, M sub O, and M sub B. And M sub A is easy. It tells us that right inside the problem there. It's 6 kilograms. Then it does this weird thing, all right, maybe it's not that weird, where it says the rods A, B, and DC have a mass of 2 kilograms per meter. So what it does there, it gives us a mass density. So we have to take the length of the rod and multiply it by the 2, and that's how we get the actual mass. Okay, so for M0, the length of the rod is 0.8 plus 0.5 is 1.3. And the linear mass density is 2, so that becomes 2.6 kilograms. To get the mass of B, we're going to do the same thing. The length it tells us is 0.75. Multiply that by 2, and we get that MA is 1.5 kilograms. Okay, so now we just execute our formulas just like before. Let's start with the disk A. So we're going to have 1/2, and it's 6 and has a radius of 0.2 meters. Okay, so that's the center of mass part. Now we got to do the orbit part or the offset part. So here we're looking at 6 plus, 6 times. Okay, so now let me scoot up here so I can show you here. Now, the point of rotation is for all the way here out to the center like that. So it's going to be 0.8 plus 0.2. So we've got 0.8 plus 0.2 squared. Okay, so I calculated that earlier, and I got 6.12. And we're in metric units, so it would be kilogram meters squared. Okay, let's go to the next one. Okay, the center rod, the one I called O. So we're going to have 1/12. Its mass we determined was 2.6, and its length is 1.3. Okay, so the 0.5 and the 0.8 together. So 1.3 is what that is, plus 2.6. And now we need the offset distance. So let's take a look at that. The offset distance in this case is from the point of rotation here over to the center of the rod, which is there. Okay. Now I know the rod is 1.3, which means from this end up to the center is half of that, which is 0.65. So I'd go 0.8 plus 0.5, all that divided by 2, 0.65. And so this guy right here, that's my offset distance, or the orbital distance. So I could put that in here as 0.8 minus 0.65 squared. Okay. Now, pause here and make sure that you understand how we came up with 0.8 minus 0.65. Because when I do this in class, there's usually some questions about how did I come up with that? Okay. So go over that, back it up, play it again if you need to. Make sure that that's solid in your head, because it's pretty important It's a pretty important bit. Well, when I run those numbers, then, which I did earlier, you get 2.256. And again, kilogram meters squared. Okay. Now we only have one bit left to do. So we got 1/12, and this had a mass of 1.5. Double check that. Yep. And its length is 0.75 squared, 1.5. And now we need the offset for this one. And that is going to be the distance from the pivot out to here. Okay, so there's my D sub B, my offset that way. Now, they don't tell us anything about how thick these rods are. Okay, so we have to assume that they're very thin, unfortunately, and that doesn't really match well with the picture. The picture, they look pretty hefty. They look pretty thick. And but since they don't give us a dimension, there's no way we could deal with that. So we'll just assume that they're thin compared to how long they are, and we don't have to worry about figuring out what halfway over is and some of those sorts of tricky bits. So this offset distance is just a half. Okay. And we run the numbers on that, and we get 0.4453. Okay, so those are the individual values for the moments of inertia. The total moment of inertia, we just need to add all these things up. So we're going to have IA plus I for the center rod plus I for the end rod. Okay. So we got 6.12 plus 0.4, just kidding. This one is 2.256. And then finally 0.443. 4453. Anyway, add all those guys up, and the number that I got was 8.821 kilogram meters squared on that baby. We'll circle it in blue because I'm feeling patriotic.